Just before midnight on Wednesday, April 9, 2014, a 911 call routing facility in Inglewood, Colorado stopped directing emergency calls to 81 call centers in 7 states. The outage was caused by a software coding error in the Colorado facility and resulted in loss of 911 service for more than 11 million people for up to 6 hours. Over 6,600 calls to 911 never reached a responsible operator. Fortunately, it appears that no one died as a result. However, the incident and the flaws it revealed is simply unacceptable. Americans rely on 911 as a reliable way to communicate in emergencies, and lapses like this cannot be permitted. The outage was caused by a software coding error and it could have been prevented, but it was not. Why did it happen in 2014 and never before? Because the architecture of the telephone network changed. Call control in legacy 911 networks was primarily performed in a central office switch that was close to the customers it served. In contrast, IP-supported networks increasingly rely on geographically remote servers and software-based components to support key 911 functions, such as 911 call routing across multiple states and jurisdictions. Consequently, a 911 outage in an IP-supported network has the potential to affect a much greater number of call centers and people across multiple states, as demonstrated by the multi-state effects of the April outage. So what was the software coding error? Before explaining the software issue, let me illustrate it with a metaphor. Imagine you're an administrator at a clinic and you need to record each patient's details, their sequential number, name and surname, age, and the doctor they are visiting. All patients are seen in order. When a patient's turn comes, you announce over the loudspeaker, "Number 5, please proceed to the therapist." You have a paper form with space for 20 entries. This form was designed years ago when no one anticipated that a pandemic might drastically increase the number of patients seen in a day. That is exactly what happened on this day. You recorded the 20th patient, but there was no space for the 21st. Keeping numbers in your memory is unreliable. You cannot risk sending the patient to the wrong doctor. Therefore, patients beyond the 20s cannot be served and are forced to leave. A similar software error occurred in the system that registered 911 calls. Each phone call was assigned a unique sequential number and recorded in the database. At some point, the counter reached a value that exceeded the maximum allowed for the data type chosen by the programmers to track the calls. When the system tried to create a record with a number exceeding this limit, the database simply threw an exception. An exception is an unlikely, unexpected event that should not occur if everything goes according to plan. In the call processing system, this exception was not handled by any algorithm, and as a result, incoming phone calls were not processed. Why did no one notice the problem? Indeed, programs typically log all unexpected events, exceptions, in a special log. IT system operators monitor these logs to ensure that no unexpected events occur and to respond promptly if they do. The system did record this unexpected event in the log. Unfortunately, the alarms were automatically categorized by the server monitoring logs as low level, and personnel did not realize what had failed or the severity of the problem. Thousands of low-level alarms failed to attract the attention of system administrators. The low-level designation was a default setting accepted by the system administrator, which, in hindsight, did not reflect the potential severity of the fault. It appears that system administrators did not fully understand the significance and scope of the problem for more than 2 hours. They only understood the issue when they received calls from 911 call centers reporting that calls were not getting through. Early in the morning, after 6 hours of downtime, the problem was identified and system administrators manually rerouted 911 calls to another facility to restore call processing. Which actions were taken to remedy the outage and prevent a similar occurrence? First, the database counter limit was increased to ensure it is no longer possible to reach exhaustion. Second, the counter value is now checked weekly to ensure it is not nearing the maximum threshold. Third, an alarm was created based on the percentage of successful calls processed compared to the total number of calls over a 15-minute sample period. Small counter size is a programming system error that could indeed have been prevented. How could the development process be improved to prevent such and other errors? First, determine the requirements for the number of calls the system must handle and design the counter size with a significant margin. Second, conduct regular code reviews to identify cases where the chosen data types are susceptible to counter exhaustion. Third, perform load and volume testing, that is, deliberately generate a very large number of calls to test how the system behaves under a high volume of data and load. This incident showed how one small programming error can jeopardize the safety of tens of millions of people. Let's program reliably to ensure such errors do not occur.